Day 40, page 888, problem 52. Let the fun begin. This one is, well, pay close attention. It's highly geometrical. So here we go. I think we actually did a problem like this last year. And I do not have access to their diagram right now. I think this is what the diagram looks like. Well, I know this is the diagram that'll work for this problem. And we're going to use their subscripts. In the thing we're trying to prove here, we're trying to prove that it's the distance between the two beams I have that emerge, well, the actual emerging beam and the direction of the original beam, the distance between those two is d. It's the perpendicular distance between those two parallel lines, is equal to tau, the thickness of the substance, times the sine of theta I1, that's the angle of incidence number 1, minus the theta transmission number 1. So T is transmission, so it's like theta 2 in the N1 sine theta 1 sine N2 sine theta 2 Snell's law equation. So I have a little bit of an advantage with colors, but I also have a difficulty drawing straight lines without a ruler. So we'll see what happens here. So far, so good. And I've done this problem before, so I know pretty much the most direct way to do the problem. But if I think if I draw the normal at the first interface, that's a good thing to do. So right here, if I draw the normal straight down, oh, it's supposed to be straight down. Let's try that again. Yeah, close enough. All the way down. All right, that's not too bad. So up here, I have theta I1. Theta, angle of incidence, number 1. Now, theta T1 is right, let's use, I'm going to use blue for now, right here. So that's, yeah, let's use blue. So right in there is theta T1, angle of refraction number 1, or they call it transmission number 1. All right, and then I have down at the bottom, down here, I guess I really don't even need to know the angles down there at this point, because everything's in terms of 1, theta I1 and theta T1. All right, so let me just do this then. Down over here, I do want to look at this distance right here. That's perpendicular. That's my D. That's the same as D. And I'm going to focus on two triangles. And I'm going to use my colors here. So if I look at this triangle right here, which I may erase in a little bit, but that triangle, it's a right triangle, and that long leg is tau, the length of, or the thickness of this medium, and that's thin angle that I have pointed to at the top there is theta T sub 1, and the hypotenuse is shared with another triangle. Let's draw that one superimposed, this triangle right here. So they're not similar triangles. They look very similar, but they're not the exact same triangle. But I do know that this angle combined, they're two thin angles there at the top that I just marked off with that black 3-hashed marker for an angle. That angle right there that I just marked off is theta I1. I'm going to call this, let's use blue again. Now let's use black. This little angle right here, right in there, I'm just going to call it, for lack of other thing to refer to it right now as, I'm just going to call it theta 3, not theta 3-1, theta 3i, theta 3t, just theta 3, because I do know that that theta T1, theta T1 plus theta 3 equals theta I1, theta angle incidence number 1, because vertical angles are equal. In other words, and those two small angles, theta T1 and theta 3, add up to combined across from the theta I1. Anyway, now what I want to concentrate on are the two triangles I have highlighted. The blue triangle, which is a right angle there, and it has a thickness, this is tau, and this is theta T1 right here. And it shares a hypotenuse. I'm going to call the hypotenuse, I'm going to call that H. And then the red triangle, which is, I'm going to separate it out right now, but it has a position sort of like that, where the hypotenuse is H, that's on top of the blue triangle, and this is D, is what we're really looking for, and this up here is theta 3. All right, now let's start using some trig here and see if we can make this work out. If I look at that red triangle I just drew, the sine of theta 3 is the opposite leg D over H. And now looking at the blue triangle, if we take the cosine of theta T sub 1, that's equal to tau over H. All right, so now you might see where this is going. I'm going to solve both of those for H. So I'm going to have H equals tau over cosine theta T sub 1. And over here I'm going to have, for the red triangle, H equals D over sine, it says sine theta sub 3. So if H equals those two things are equal to each other. In other words, tau over cosine theta T sub 1 equals D over sine theta sub 3. And we're just about done. I'm a little out of space. I'm going to go over here to the left. Solve that for D. We have 2 steps left, so go way over here. So you solve that for D, and you end up with D equals the sine of theta sub 3 times tau. I guess they had tau at the front of that expression, or yeah, front of that expression, over cosine theta T sub 1. So what I'm going to do is I just got to get rid of theta sub 3. If you go back way up here to the top right here, this circle, if you solve that for theta sub 3, and once again, that's kind of the key to this problem. The two keys are drawing those two little triangles, and then that relationship right there, that the sum of those two small angles equals the original angle of incidence. You might need to look at the diagram again to convince yourself of that. But that is indeed, vertical angles are equal to each other, and the theta T1 and theta 3 together make an angle that's opposite, or it's called a vertical angle with theta I sub 1. In other words, you just plug that in there, and I'll just rearrange like they did. Bottom line, you just plug that in. Well, solve for theta sub 3. Theta sub 3 is theta I1 minus theta T1, which is what we're trying to prove. So that basically just proves it. I'll just write it down, put the tau in front, commutative property of multiplication, times the sine of getting rid of theta sub 3 is just the sine of theta I1 minus theta T1. I got an extra set of parentheses in there, doesn't matter, over the cosine of theta T sub 1. So wow, way to go. Nice job. That looks awesome.